Um, First of all, good afternoon, everyone. I also like to start by saying a big welcome to T-Systems, to the community, to the Eclipse Foundation. I also would like to say a big thank you to the Eclipse Foundation itself for promoting such a collaborative environment for us to bring ideas and projects. And last but not least, say a big thank you, good morning, good evening, good afternoon, depending on where you are, for the online attendees. I'm Filipe Prezado, which is, I don't know if mine, doesn't let me. Great. I'm Filipe Prezado. I'm a program manager in the Azure Mobility team, a team that is working and focusing on the automotive industry. I'm not alone here, although I'm the speaker and I'm the guy that codes PowerPoints, not coding the applications that you are about to see, but we are a team that is contributing, and we are working and collaborating with the ecosystem. And so I also would like to highlight that we have two developers here on the team. So Patrick, Daniel, if you can just stand up quickly so the audience knows that you are here. And you can talk with them, and I encourage you to talk to them. We also have additional PMs, so Greta, Fred, Alex, and Mario, they all work on the same team at Microsoft, where we want to collaborate with you and the industry. So, Project Ibeji. Anyone want to try? Yeah. So that's an interesting, and let me, When we have the second contribution, and so for the ones that have been here on the first contribution day, we have another project called Carriot, and you'll see that it's a Carriot written in two T's, which you'll say those guys made a mess up, and they actually kind of submit it like that. So Ibaji, when we were looking at the code name for this project, we wanted to represent a little bit of the culture, a little bit of the openness, a little bit of the world collaboration to the projects under Eclipse Foundation, and last but not least, a little bit about the twins itself. And so our second contribution day and our second project to the second contribution day is all about in-vehicle digital twin. And so we would like to work with you, and you'll see that at the end of the talk, we have more questions than answers. We have code to show you during the walk and during the talk, but it's really about using and expressing a digital representation of the vehicle, states and functions that allows you to accelerate and democratize the programming of in-vehicle applications by accessing the vehicle state and functions. But with this, we also think that we could work with you to bring some of these capabilities to the cloud itself, where you could virtualize the vehicle and the vehicle digital twin, and you could also accelerate the development and test the vehicles by using this simulation on the cloud itself. I also want to highlight that although we call out on the slide that a modern application programming model like Eclipse Carriot is designed to work together with Ibaji, other application program models and other projects that I've been seeing and we have been working together here in the community, like, for example, Bosch Velocitas, but also, for example, Bosch Cuxa, those two projects that are contributed here on Eclipse, they have, and we have an opportunity to collaborate all together. So from this perspective, what we are bringing to the community is all about bringing some of the developer experience that we have at Microsoft, building large-scale cloud-native applications, building some of our innovation and research, for example, on this digital twin definition language, and again, advancing the state of the software-defined vehicle. So, what is DTDL? So it's an open language, right? It's a programming tool. You can see it is not yet another specification. It was designed for IoT platforms. It was designed to represent entities. But if you go, and again, using the model of open source, and the specification itself is open, and the link in GitHub is there, it allows you to model other industries. So when you look at an SDV, when you look at the in-vehicle, when you look at the car, and you look at the relationship that the car has with the infrastructure or the vehicle to everything, you'll see, for example, that in the DTDL contributions that we have on the open source, there are implementations for a smart city. There are implementations for an energy platform system. So we think that bringing this to the community and bringing this to the ecosystem and to the automotive world would help us drive the community itself. So when we took the definition language, and again, I'm bringing a programming tool, I'm not bringing a product. You might have seen from the stack of platform as a service components on the Microsoft cloud that there is an Azure digital twin. This is not what we are talking about. Yes, Azure digital twin is built upon DTDL. But what we are bringing is the specification, and looking at the specification and seeing how we can model it with a couple of capabilities that allows us to model the vehicle in the vehicle itself and not in the cloud. Of course, if the language is successful and the implementations are successful, then bringing the representation of the vehicle to the cloud using the same definition language will be much more seamless and accelerated. So the definition focuses on the vehicle providers. So how you expose, how you define your vehicle itself, how you expose your aircon, how you expose the temperature, how you bring semantics to something that is most likely just a schema or a type. So it's all about what we bring with DTDL. How we allow DTDL to express the differentiator that you want to bring to the vehicle. So if you think about bringing, imagine you have a use case where you bring an abstractor of a dog detector. And you might recall, some of the audience, that the dog detector is a use case that we had on our first application program model. A dog detector can be implemented with an in-memory or an in-vehicle, for example, machine learning model, but could also implement it with a cloud model, or it can not even use computer vision, for example, could use audio. So the idea of expressing these differentiators through DTDL, this is the value of the language itself. Then, of course, the language and the specification allows you to version, allows you to maintain the state and the functions of the vehicle across the lifetime of the vehicle itself. And so it allows us to provide building blocks for the vehicle digital twin itself. And so the vehicle digital twin is the representation in the car that allows you to have a single place to access all the hardware, abstracting the complexity of the hardware so that our developers can focus on the applications itself, again, on the dog detector, on the pet detector, on the kid detector, on the smart wiper, but can also be a place for us to control policy access. Whenever I want to give the camera, for example, to detect if my kid is in the car, because I have an application for that. If the camera is being used currently by the other system, there is a policy that says, no, you cannot use the camera. So let me use some other capability that the vehicle exposes, like, for example, audio, to reach and give the capability to the application itself. And again, by having this vehicle digital twin, we have an up-to-date database so that we know exactly the change that the vehicle fleets and the vehicles have across the time. So how does it look like? And again, this is a code-first approach community. So we brought some code here, and I will just highlight some of the key concepts of the vehicle digital twin, or the DTDL language, that is used to represent. You see here two properties that have some semantics already associated with it. So the property is the dog mode on and off switch that I would like to use in my application in the car as a semantically defined that it can be remotely accessed. So from this perspective, you can say, okay, whenever I want to use the dog mode on and off switch, I can access it remotely outside of the car or not. This is one example of using the property concept. The other concept that you have here is that there is a schema associated with this. So we know that this type of property is of type string, but it has a rich type or system associated with DTDL itself. And I will not bother with booleans, ints, and so on, but that exists as well on the language. Last but not the least, it has, under the remote access semantic, there will be some operations that the on and off switch allows me to consume. And you will see later in our presentation in Eclipse Chariot that those operations are represented as intents. So whenever I'm building an application for the car, and I want to build that dog mode detector in the car, I want to query the vehicle digital twin if the vehicle knows about a dog detector capability. That dog detector capability could be brought by one of our partners, someone that has a service inside the car, right? So he builds an application, he brings the application. The application calls into the vehicle digital twin, looks and says, okay, vehicle digital twin, if you have a dog detector, what can I do with it? And I can discover, I can inspect, I can read, I can access. And so those remote access properties you see there allows you to talk with the vehicle itself, and then again, for example, say, turn on the dog mode detector because I'm about to leave the car. Or, again, if there is AI there, instead of you turning on manually, the AI itself will turn it for you. So how are we realizing this? Through the implementation and the code that we are submitting to Eclipse. From the ones that have seen our previous presentations and the architecture we brought in under the Chariot application program model, we brought the concept of the vehicle integration providers. This is not the Microsoft space. This is everyone that is in the automotive industry that has ECUs, that has additional compute. They bring it to the car, and if they represent those capabilities and differentiators in DTDL, then the applications that are going to consume them will benefit from them. So we facilitate, and we don't want to work on implementing those vehicle integration providers. But of course, as a community with code, we show with a sample of a mock, right, how, for example, a temperature could be exposed, in this case, as a vehicle integration provider. And so you see that as a DTDL represented part of the considered, for example, an ECU. Now, the ECU itself, when it announces to the vehicle digital twin in a dynamic way, it needs to do what? It needs to register itself. Think about a vehicle in the future that allows you to have a smart trailer. The smart trailer, when you plug it to the car, the smart trailer might come, for example, with a GPU, or might come with a set of additional cameras. And so when that smart trailer connects to the car, you have a way for the vehicle digital twin to be dynamically notified, register the capabilities, and advertise those capabilities upstream for the applications to consume. So this step of taking the DTDL from the multiple vehicle providers and aggregating into one of them, we have an implementation, again, just to show how that step is doing through the parse. Then, of course, you want to build a view of the car. Now, this is one of the topics you'll see at the end of the slides that we are asking the community to collaborate and discuss with us. Because do you have a canonical model of a car? Do you know how, when I bring a DTDL from a provider that has an ECU for a window, is it for the left or for the right? Is it for the rear, the front? So that canonical model, the vehicle as a model itself, do we want to bring it part of the DTL definition, or do you have an outside process to check against? And so the relationship that you build to build your vehicle store is an area that we are seeking collaboration with the community to advance it. And so that's what this says. So you get those capabilities, and you combine into the vehicle digital twin representation. Last but not the least, you want your applications to be able to have and to consume those. So you have an intent. Instead of me saying, I want to call function A to the specific temperature controller inside the vehicle, I have an intent to know if there is a dog detector And if that intent to use a dog detector tells me it comes with a camera, it comes an AI model, it comes with these other capabilities, then the application itself can dynamically adjust itself and start consuming those capabilities. And so that's what these intents and operations talk about. So with this, and I've been talking for quite a lot, I'm going to show you a 5-minute video, which is a code implementation of just what I've guided through. It's done by Ash Beats, one of our software development engineers in Redmond. He would love to be here, but it's, I think, something like 2 a.m. in the morning, so it'll be hardly difficult. But again, any feedback you'd like to share with us, we welcome, and either through GitHub or through directly with the team here, just let us know. And now I invite you to just, 5 minutes, watch the video.
This demo will show our initial proof of concept for using DTDL to help realize an in-vehicle digital twin. The demo will first show how a provider registers the DTDL for its resources with the digital twin service. It will then show how a consumer that we create specifically for the demo can query the digital twin service for the DTDL for a specific resource and subscribe to that resource's data feed. The resource that our demo will target is the ambient air temperature inside the cabin. For this demo, we will use 3 terminals, one for the digital twin service on the top, one for the provider in the middle, and one for the consumer on the bottom. We'll start the demo by starting the digital twin service. Once started, the digital twin service can serve incoming requests. Next, we'll start the provider. The provider first prepares the DTDL for its resources. An example of this DTDL was shown in one of the earlier slides. Next, the provider registers the DTDL with the digital twin service. This is done with a gRPC call. In the digital twin services terminal, you can see the ID of each of the resources that it registered. The provider has also started a background thread that generates simulated data stream of temperatures ranging from 65 degrees Fahrenheit to 85 degrees Fahrenheit. These values will represent the ambient air temperature inside the cabin. For the purpose of not having too much white noise, the demo will only have a simulated data feed for one of the provider's resources. Finally, we will start the consumer. The consumer is focused on just one resource, the ambient air temperature inside the cabin. The consumer sends the digital twin service a find by ID request for the DTDL for the ambient air temperature inside the cabin. This request provides a well-known ID for the resource. In the digital twin services terminal, you can see the digital twin service acknowledges receiving the request and it acknowledges responding to it. The response sent back to the consumer contains the resource's DTDL. Let's go and have a quick look at that. Next, the consumer passes the DTDL and extracts the URI. That it needs to subscribe to the resources data feed. There are additional details in the DTDL that can assist a consumer with the resource type information and the operations that can be used when working with the resource. We only need to use the subscribe operation. And in inspecting the DTDL, we can see that the subscribe operation is available. The consumer uses gRPC to invoke the subscribe operation with the URI provided. The call includes the ID of the resource that we wish to subscribe to and the URI where the value should be published to. Once the consumer has successfully subscribed, it starts receiving the resource's data feed. This concludes the demo. Let's take a look at the layout for the code executed during the demo. Opening the demos project with Visual Studio Code, we can see the top-level layout. We chose Rust as the programming language for this demo. DT Consumer contains the code for the consumer. DT Provider provides the code for the provider. DT Service contains the code for the digital twin service. DTDL parser contains the code for the DTDL parser. It also contains the sample code for the demos, DTDL, and the context file used for DTDL. The proto directory contains the protobuf files used by gRPC calls for the digital twin service, the producer, and the consumer. That concludes our overview of the project layout.
Thank you, Ash. So the open source community allows some, I'll say, quite some advancement and fast collaboration that is not, for example, expressed in a demo like this. When we were building the prototype, the JSON-LD parser from the Rust crates actually panics with one of the latest versions of the compiler. So we end up to open an issue in the nightly build. And so we created these, and someone on JSON-LD team actually fixed this for us almost like overnight. So if you see this kind of interface, communication, collaboration over GitHub with multiple communities of developers, architects, program managers, this is the power of open source, and this is what we would like to bring here to the community. Again, with the code public, there is a lot to be done here. You'll see in the next slide. I'm about to finish. But you'll see in the next slide that there is a lot. But the power of the community, the power of having the GitHub issues, and you can submit, and you say, Filipe, this doesn't work, or this has broken, or what do you think about this issue? What do you think about this feature? And this is really the power of open source. And one of the reasons why I think Eclipse Foundation, with the code-first approach, the collaboration and the communication through something like GitHub, accelerates the development for software-defined vehicle applications. So what you have seen from the demo, and you'll see an update in, roughly speaking, 1.5 hours from the Carriot itself. The Carriot is the application program model. Yes, again, we look at them together, but I want to emphasize that they are not to be used together. So for example, like Velocitas, like Cuxa, if there is value in some of these components that we have, this is where we would like to go with the community. And the same is true, for example, for Carriot and for everyone else that is here on the community itself. So you'll see later on that the dog mode logic and the dog mode UI will come as an application, an in-vehicle application that consumes the application program model and uses the concepts of the vehicle digital twin. So Carriot offers the registration and the brokering of those events and allows to understand those intents in a dynamic way. You will see that the in-vehicle digital twin, and I hope that from the demo, and again, through the code, you are able to see the abstraction level that we can bring by providing low-level access, but simplifying the access to those capabilities itself, to the vehicle state and the functions. You'll see a dog detector. Again, you'll see a very detailed implementation of that dog with an application that does object detection, that talks about machine learning, but the concept itself as an application that allows you to integrate with other applications in the car, that's what we want to bring. And last but not the least, the consumers as an example. And I really like the way you, Tom, presented the SDV application side so that we can start looking at how the applications and the in-vehicle value for our users, drivers, passengers, everyone, essentially the consumers, that's how they realize SDV, right? Everything else is just code that we geeks love, but we need to think that my wife doesn't care about codes, and my wife just wants to take the car and the dog that you'll see later for a nice walk and make the dog safe, and actually allows me enough time so that I can focus on the code and I don't have to, you know the drill. So with this, it's a community, it's collaboration. We are going to make proposal for us to host an in-person and virtual meeting, a technical community meeting of Eclipse dedicated to the in-vehicle digital twin. We'd like to do it in Redmond for those who can travel. Dates to be defined, of course, and we have a couple of topics. And I want to close the session by saying that the topics that you see here, they just fundamentally show that we don't have we don't have an end product, we don't have a project. It's actually to promote community discussions. Yes, we went through a couple of painful process by building that demo, as I just highlighted on the compiler thing, but then again, how do we build a canonical model for a car? Is the in-vehicle digital twin an instance or a model, or both? How we build vehicle store implementations, how we make it in memory, persisted, graph, key value store, and so on and so on. And so with this, I want to say a big thank you to the Microsoft people, but also to some of the members here on the audience that I had the opportunity to talk about these concepts of vehicle digital twin. And with that, I'm concluding my talk with 4 minutes for Q&A. Thank you.
I highly appreciate that you take care about the dogs, right? So having that storyline is really nice, and it's all through all the projects. I did not explain the way how we ask questions. So, questions from the on-site audience. We have 2 microphones there and over there. So if you have questions, just stand up, go in front of the microphone. For all the people participating online, you could raise your questions in the chat, and we will read out the questions out loud here, and then Filipe can answer, and all the audience here can all understand the question. So, Paulina, do we have questions from the online chat?
So in the demo, the provider, consumer, and digital twin are all expected to run in the vehicle. What is the difference use case for using in-vehicle versus in-cloud twin?
Yeah, that's a very good question. Thank you for asking. The cloud brings additional capabilities, for example, for us to manage our fleets. It also brings capabilities for us to accelerate the development so that the developers can actually simulate the full vehicle in the cloud. That's an Uber state. We cannot do that today. For example, if we look at how we could virtualize some of the ECUs that we use in the car itself. There is no path there, but at the same time, it is just a technical problem that we can put our brains all together and try to fix it. So the cloud side allows quite interesting use cases where you look at a fleet management of your fleet. Can allow you, for example, to think about that you want to do a statistical sampling of your vehicles before you go into SOP, and you actually use the definition of the vehicle digital twin to create that statistical representation that gives you enough confidence that if you test those vehicles, your other vehicles are certifiable. It's an Uber vision. But again, as a community, and what we need to accelerate the development of our industry, that's some of the use cases that I would see, for example, for the cloud side versus the in-vehicle part.
Any other questions? Yep, please. Great, but please come to the microphone that everyone can, all the online people can hear your question. Without a microphone, it would be difficult for the online participants to understand what you're asking.
So what you're proposing is probably the digital twin becomes like an abstraction layer in the vehicle where the outer world actually interacts with the vehicle through the digital twin, or it's again one more interface that you can interface with?
That's a great question. So let me unpack that. Talking always through the vehicle digital twin always introduces yet another step, yet another latency, right? Yet another process. So I think the question is actually something that we'd like to discuss with you. We do see the vehicle digital twin as really abstracting the vehicle, right? And vehicle states and functions, being able to support the dynamic registration of the capabilities. Now, as soon as you know if a capability exists, do you talk directly to the vehicle digital twin, or talk directly to the application that is providing that capability? It's a use case detail. I would say most likely in some scenarios it has to talk directly because of performance reasons and many others. In some other cases, you could still continue talking with the vehicle digital twin, or you could use the broker to do that for you. So it's part of a full architecture that I think we need to work and discuss in the technical community meeting, like we have been, for example, in the past one discussing. I don't have an answer. I would love to get the answer from you. And again, just go PR, issue, questions, call, Teams, whatever. Okay, thank you.
Thank you.
Any other questions? Paulina, do we have online questions? More? Let's see. We still need to trade this way. Oh, there's, please, sorry, go ahead. I just was assuming you would take back the microphone, so, but please go ahead.
I did, but I also have a question. So
Great.
I was wondering the meta model itself, so DTDL, is that something that is part of this project as well?
No. DTDL is an open specification for Microsoft. We use it in cross-industry scenarios. We would like to bring it to the community to see how does it fit into the automotive. So DTDL itself is the way Microsoft today works in collaboration across open source, but also how we see our power and capability to bring to the community. I can bring the DTDL team to talk with you directly. It's not part of the It's not specific tied to the project. It's an open specification. We just think that in the automotive can bring additional value. Like, for example, some of the other capabilities that we have that we can bring from other teams and not necessarily just constrain it to this project and to this industry. So again, it's using the differentiators of automotive on some, I'll say, open source technology or open technology, open specification technology that we have available.
An open specification from Microsoft actually means?
Yeah, that's a good question that I'm happy to take offline, given that I think we are on time. We are working on this, on looking at the DTDL as an open source. That's what we can say at the moment. Today is open. You can have access to the specification. It's fully documented. It means open specification. I know that the question implies what it means. Yes,
okay.
We are.
But it's not
something
open
that
in
I
the
can
form
take
that
offline.
I can influence it.
Yes, exactly.
Okay.
It's something that I can take offline with that. Okay.
Yeah.
We need to engage with the DTDL team to get a formal answer.
Maybe one last final question. Do we have something on the online channels? We don't have. Any questions here from the audience? No? Then, Philippe, thanks a lot.
Okay,
I think